Welcome to a simple guide to mediation, enhanced with narration and fancy slide transitions. Please feel free to pause, fast forward, or rewind this video at any time. Mediation refers to causal relationships somewhat more complex than the simple X predicts Y relationship. When hypothesizing and testing for mediation, a mediating variable, M, plays some role in the relationship between X and Y. Thus, we are hypothesizing that the relationship between X and Y is somewhat more complex than the simple direct effect from IV to DV. Additionally, more complex mediation can also take place, for example, with two mediating variables. But testing more complex mediation is not only beyond the scope of a simple guide to mediation. There is also not currently an accepted or agreed upon method for testing these types of mediation, so we're going to keep it simple. So why even consider mediation? Why not just predict and test direct effects? Often the reason is because we believe that some X really does have some effect on some Y, but we want to ensure that there is not a more accurate explanation for this cause and effect relationship. For example, let's say we want to predict what causes people to either use an umbrella or not. We may say that rain causes this effect. However, this does not explain why many people do not use an umbrella when it rains. Thus, we can explain more of the observed behavior in our sample if we include a mediator called desire to stay dry. Rain causes those who wish to remain dry to use an umbrella when it rains, and those who do not have this desire do not use an umbrella. So in this example, desire to stay dry mediates the effect rain has on using an umbrella. Without the mediator, we can only explain the behavior of those who use umbrellas in the rain, whereas with the mediator, we can also explain the behavior of those who do not use umbrellas. Just as with other hypotheses, mediation suggests a cause and effect relationship between variables. However, remember from previous lessons that causation is not implied by correlation, and statistically, the IVs, DVs, and mediating variables will likely be correlated. Thus, it is critical to develop mediation models based on theory first, then to test and support the theoretical model through statistics. To illustrate this point, consider the relationship shown. Self-efficacy mediates the effect training has on performance. In other words, training affects performance through self-efficacy. That makes sense. Now consider this alternative model. Performance mediates the effect training has on self-efficacy. Well, that also makes sense, and it is supported by statistical tests. Now consider these other models. They also make sense in certain contexts, and they are also supported by statistical tests. So which model do we choose? Most likely, we have a certain theory and model in mind prior to doing the statistical tests. Our advice to you is to let this a priori theory guide your model development rather than first seeing what the statistics say, then developing a model. See Matthew and Taylor 2006 for a more in-depth discussion of this specific example. Now, there are three main types of mediation. The first is called indirect effect. Indirect effects predict no direct effect from X to Y, while leaving the mediator out of the model. However, X has a direct effect on the mediator, and the mediator has a direct effect on Y. Thus, X is said to have an indirect effect on Y. This hypothesis can only be supported if the direct effect of X on Y is insignificant prior to testing for indirect effects. The next type of mediation is called partial mediation. Partial mediation predicts significant direct and indirect effects from X to Y. Thus, the unmediated relationship is significant, as well as the X to mediator and mediator to Y relationships. In order to avoid concluding that a partially mediated effect is significant when in fact only the three direct effects are individually significant, a significance test for mediation must be performed. This will be explained more fully on the next slide. The third type of mediation is called full mediation. Full mediation predicts that the direct effect of x on y will be significant only if the mediator is absent. When the mediator is present, this direct effect becomes insignificant, while the indirect effect is significant. Lastly, if the x to mediator and/or the mediator to y relationships are insignificant, no mediation is taking place. Using the Bencare constructs dataset, we can test for mediation in Amos. You may find it helpful to reproduce this model and table on your own. You should already be familiar enough with Amos to do this without a step-by-step guide. But just as a reminder, don't forget to use standardized estimates, and to estimate means and intercepts because some of the data is missing from the dataset. Also, as you already know, the regression weights table is found in the Estimates section of the Output window. Next, include the mediating variable and run the model again. Notice the change in path coefficients when comparing this mediated model to the direct effects model on the previous slide. You'll notice that the direct effect from trust and company to loyalty for long term has dropped out of significance, whereas the direct effect from trust and agent to loyalty for long term has simply been reduced, but is still significant. The reason for the reduction in the path coefficients is due to the mediating variable explaining some of the variance in the dependent variable that had previously been explained by the independent variables, but is more appropriately explained through the mediator. Now, just because there appears to be mediation does not mean that mediation is significant. As explained earlier, the apparent mediation may actually just be 3 direct effects, rather than a mediated effect. In order to test the significance of a mediated relationship, you'll need to find the regression weights table in the Estimates section of Amos Output window, and use the values indicated in this slide to fill in the appropriate boxes on the Sobel calculator. Then press Calculate and use the two-tailed p-value to determine significance. This test actually has its limitations. For example, it is sensitive with sample sizes less than 200. Next semester, we will offer a more detailed explanation, including how to conduct bootstrapping in Amos. So, we found that overall value partially mediates the effect of trust and agent on loyalty for long term, and fully mediates the effect of trust and company on loyalty for long term. Please follow this style of wording, both for your hypotheses and for reporting your findings. Time for a little practice. Follow the instructions on this slide and see what you come up with. Please email me your findings. And now, the moment we've all been waiting for. Please pick 3 stress factors from the Sohana dataset and follow the instructions on the next 2 slides.